Hello, good afternoon everyone. In this lecture, we will be discussing about CPU scheduling or the central processing unit scheduling, which is one of the main function of operating system. And CPU scheduling is very important topic in operating system in general. So let us try to understand and see what is the CPU scheduling and what exactly it does, or what does it does. So this module was also uploaded to you in the Google Classroom, I think 2 weeks ago or last week. I can't remember exactly when, but at least you have the copy already. And then I asked you to study this topic in advance, so I hope that you already get familiarized with those what is written here in the module. Okay, so CPU scheduling. So I don't have to, I intended not to explain all of this, especially this, like let's say for example, the criteria, the algorithm, the optimization criteria, because we will be focusing more on the scheduling algorithm. But first, I will just give you the introduction or a little bit about CPU scheduling. So when we say CPU scheduling, it is the basis of multi-programming operating systems, since the processes that we have now, like the way we use our desktop or laptop or mobile devices, it is more on the multitasking already. So meaning to say multi-programming, we are actually using a multi-threaded or a multi-programming operating system. So CPU scheduling plays a vital role in doing that, because when we say multitasking or multiprocessing, it involves scheduling, the prioritization, and the algorithm that is being used when we are doing or dealing with CPU scheduling, which is one of the main function of operating system. So by switching the CPU among the processes, since whatever we do with our computer or whatever we do with our desktop, we are using the operating system. So by switching the CPU among the processes, the operating system can make the computer more productive. So the more refined, or the more correct, or the more clear CPU scheduling, the more things that you can do, or the more tasks that you can do in your computer, and then obviously it can make you more productive. So multi-programming operating system, they work on the basis of CPU scheduling. See, so multi-programming is very connected or very relatable to CPU scheduling. And why is that? That is because by switching the CPU among the processors, because multi-programming or multitasking involve multi-processors. So by switching the CPU among processors, the operating system can make the computer more productive. And now, you may be thinking, why did we say that by switching the CPU among processor, it will become more productive? So this is the actual thing that is going to happen. Let's say for example, on the real scenario, right? So this is the actual thing that is going to happen in CPU scheduling. We are going to switch the CPU among different processes, and thereby we are going to see how the productivity of our computer, So if, let's say for example, if you are using your laptop, and then you are watching video, you're doing with your Excel, and then you are also at the same time you're also browsing the internet, all of those things are processes that is the most vital thing that the operating system is functioning, is the CPU scheduling. Sometimes we can we think that the processes that is being shown, or the processes that's being run into your computer, are doing it at the same time when it comes to CPU scheduling, but it's not. So we will discuss it later. By discussing further what is the scheduling algorithm, and what are those method that is being used in that algorithm. And By this we will also discuss, or I think we just go through with the what is CPU scheduler. So a CPU scheduler, or a short-term scheduler, selects from among the processes in ready queue and allocates the CPU to one of them. So CPU scheduling decisions may take with the four. If you can still remember this process, the topic that I think it's lesson 3, the topic that I discussed to you about the process with the illustrations or the figure that is from the running state to waiting state, running to ready state, waiting to ready state, and then it terminates. So those are the schematic or the diagram wherein how the processes involved, or how the process is being run until it completes or until it terminates. And then what are the scheduling criteria? So we have CPU utilization. So when you say CPU utilization, it keeps your CPU as busy as possible. So, wala siya matawag ng idle time, meaning to say, wala siya bakante, no idle time. So, it keeps on running as long as you enter another process. And then we also have the throughput, the number of processes that completes their execution per time unit. And then we also have the turnaround time, meaning it's the amount of time to execute a particular process. So, what is the total run time or the total turnaround time, or the interval from time of submission to the process to the time of completion of process. So it takes a lot of computation when it comes to the total number of running time. And then we also have the waiting time. So amount of time a process has been waiting in the ready queue. So we have the queue, the processes are being lined up. So for those processes that are on the kanang waiting time, are what we call naka-queue siya. And then we also have the response time, the amount of time it takes when the process was submitted until the first response is produced. This is not an output, but it is more on the time sharing environment. And then these are the criteria for the algorithm optimization of scheduling. So we have the first one is we have a maximum CPU utilization because of this algorithm. And then we have maximum throughput. We have a minimum turnaround time, a minimum waiting time, and a minimum response time. So these are all those positive criteria. So those criteria helps your computer, or helps the processes of your computer to be optimized when it comes to faster and easier to navigate processes. So these are the algorithm. So algorithm are either, there are two categories of algorithm. Either we have the non-preemptive or the preemptive. So when we say non-preemptive, are those algorithms that design so that once a process enters the running state, it cannot be preempted until it completes its allotted time. Now, compared to preemptive scheduling, it is based on priority. So where a scheduler may preempt a low priority running process anytime, or when a higher priority process enters into a ready state. So meaning, wait a minute. So meaning a preemptive type, or a preemptive type of algorithm is preemptive algorithm is more on wait a minute. So to continue, these two categories, namely the preemptive and the preemptive, basically the difference between the two is that a preemptive scheduling is that it can be preempted, meaning the processes can be scheduled. So the process can be scheduled, whereas in the non-preemptive scheduling, the process cannot be scheduled. So these are the two difference between this algorithm. So I think there are four scheduling different types of scheduling algorithm. We have first come first serve, or the FCFS, and then we also have short job first, or the SJF, and then we have priority scheduling, and then we also have the round robin scheduling. So first we will discuss further about the first come first serve scheduling. So when we talk about first come first serve scheduling, this scheduling algorithm simply scheduled the job according to its arrival time. So meaning the job which comes first in the ready queue, meaning to say when you have the queue, the first job or the first process that is being inputted will get the CPU scheduling, or will be the first process that the CPU will reschedule or will schedule. So the example is here. This is the example. So again, when we talk about first come first serve type of algorithm, the job are executed on time on first come first serve basis. It is a non-preemptive scheduling algorithm, and then mostly poor in performance as average wait time is high. So again, first come first serve algorithm, scheduling algorithm, is the first process which comes first in the ready queue will be the one, or will exactly get the CPU, or may unahon of process or schedule sa CPU. So let's consider this figure. This is what is called a Gantt chart for the above process, and this is the average time. If you can see this, we have a process 1, process 2, process 3, and process 4 in the given below. And then each of the process has its burst time. So when you say burst time, burst time that we consider here is used when a process switches from running state to ready state, or the waiting state to ready state. So again, the process algorithm, the process schematic diagram, wherein when the process comes in, the waton siya waiting, and then until it terminates. So these processes have 4. We have P1, P2, P3, and P4. So again, ang burst time is used when a process is switches from running state to ready state, or from the waiting state to a ready state. So si process 1 naa siya 21 ka milliseconds. So the time we're talking about here for milliseconds, because as we all know, when we use our computers, it's super fast. We cannot even imagine how the processes are being switches from one another. Sometimes we think that all the processes or all the applications that is being run into our computer, it runs parallel only, or it runs at the same time, but it's not. So that's why the time we're talking about milliseconds here. So P1 has 21 burst time, meaning the time from the first process up to up to its completion, or until it terminates. You see here, the CPU decision may take process when a process switches from running state up to the time it terminates. So when we say P1, we have 21 milliseconds, and then we also have P2 for 3 milliseconds only. So this process is very short, only 3 milliseconds. P3 is 6 milliseconds, and then P4 is 2 milliseconds. Now, if we are using the first come first serve schedule algorithm, the average waiting time will be, so you add all the time for the 4 processes, so it will be 18.75 milliseconds. Now for the Gantt chart, since we are using the first come first serve, of course we really do not consider the burst time. However, we will only consider the job that came first, or the job that arrives first, because the job that arrived first, or the process that arrived first, will get the CPU scheduling, or will be the first when it comes to CPU scheduling. So P1 has 21 burst time, so plus P2 automatically it will be 24 milliseconds, and then P3 plus 6 it will be 30 milliseconds, and then 4 plus 2 it will be 32 milliseconds. So this will be the total number of milliseconds for your process to get through, and then the average waiting time will be 18.75 milliseconds for each processes. So this is how it goes. Now, whereas shortest job first, or the SJF, is this is the non-preemptive or the preemptive scheduling. It can be a non-preemptive or a preemptive scheduling algorithm, and then this is the best approach to minimize the waiting time. So here na sad ta mag-focus na sad ta diri sa waiting time for each process to be completed. Now, when we say shortest job first, it is an algorithm. It is a type of algorithm or scheduling algorithm in which the processes having the smallest execution time is chosen. Meaning to say, bisan siya pa'y nag-una sa queue, but its burst time is way more, mas taas ang time, or it takes a lot of time. Ang i-choose niya is the processes that has a smallest execution time. So it is being shown here. Again, this is a non-preemptive. Consider the below. So it could be non-preemptive or preemptive. So when we say non-preemptive, it will be considered the below process available in ready queue for execution. So when arrival time is 0 for all the given time, and the given time for the burst time. So let's see here in the illustration. So we have a table here still from the process P1 to P4, and then we have the burst time, still the same illustration as what we have in the first come first serve. For the P1 we have 21, P2 we have 3 milliseconds, P3 6 milliseconds, and P4 2 milliseconds. Now, since the first process to be executed in the CPU scheduling will be the smallest execution time, we will choose P4. So since P4 is only 2 milliseconds, so P4 we have the second one is the P2, which has 3 milliseconds. So if you add it, it will be 5 on the second process. And then for the P3 we have 6 milliseconds, so we have 11, a total of 11. And then the last one will be the slowest or mas taas ang time when it comes to the execution. So it will be 32. Now, the average waiting time will be, if you will add all the time, the execution time, it occurred between using the shortest job first. So it will be 0 plus 2 plus 5 plus 11 divided by 4. So it will be 4.5 milliseconds only. So again, it says here that this is the best approach to minimize the waiting time. Now, we also have on the preemptive shortest job first, using the preemptive, the earlier one is the non-preemptive. So in the preemptive shortest time first scheduling, jobs are put into the ready queue as they arrive. So as the process arrived into the ready queue, the process with shorter burst time arrives, the existing process is preempted or removed from execution, and the shorter job is executed first. Same with the objective that the smallest execution will be the first one to schedule in the CPU scheduling. It's just that, again, ang preemptive is, when we talk about preemptive, the preemptive scheduling can be preempted, that is process that can be scheduled, na scheduled ang process niya, whichever is the priority, or whichever is ready for the queue, as long as it is have for the shortest jump first, as long as the time it has the smallest execution time. Now, still the same illustration, we have P1 to P4, burst time is the same, arrival time is different. So P1 has the arrival time of 0, P2 1, 2, 3. So for the Gantt chart, we have the first one to execute, although the first arrival time is P1, since 0 is the arrival time, and then we have the P2, the P3, and then the P2 again, and then the P3. So if you're going to, the average waiting time for the preemptive shortest job scheduling is less than both non-preemptive short job first scheduling and the first come first serve scheduling. So if you can see it here, the P1 will be the last to execute. So still it has the smallest waiting time, or the average waiting time is the shortest, since milliseconds is it's only 4.25 milliseconds. That is for the preemptive shortest job first. Okay, and we also have the priority scheduling. So when we say priority scheduling, this is also a category of a scheduling algorithm wherein it is a non-preemptive scheduling, meaning to say it cannot be scheduled. Whatever it is already. So it is a preemptive scheduling, and one of the most common scheduling algorithm in batch system. So priority scheduling is one of the most common scheduling algorithm in batch system when you have batches of processes to be executed in the CPU scheduling. So each process is assigned first arrival time. So less arrival time process first. So ang less arrival time process first. So the less time arrival, the first to execute in the CPU. So if two processes have the same arrival time, if there are two processes that have the same arrival time, then we compare it as to the priority, because since this is priority scheduling. So if two processes have the same arrival time, we have to choose which is the priority. So it says also here that again, priority scheduling is the non-preemptive algorithm, and one of the most common algorithm in batch system. Process with highest priority is executed first, and so on. A process with the same priority are executed in the first come first served manner. So same, we have P1, P2, P3, P4. Burst time is still the same. We have 21 milliseconds, 3 milliseconds, 6 milliseconds, and 2 milliseconds for those processes respectively. So the priority will be, the first priority will be the P1, P2. Second is P1. P3 is, P4 is the third one, and then P3 is the fourth one. So since P2 is the first one, we have to put P2 in the buffer queue, and then P1, and then P4, and then P3. Since P2 is the priority, and then second priority is the P1. So if we are going to compute the average waiting time, it will be 13.25 milliseconds, since we are doing it on a priority basis. Okay, and then the last one is the round robin scheduling. Okay, a round robin scheduling, this is a type of CPU scheduling algorithm where each process is assigned a fixed time slot. So it will be on a fixed time slot in a cyclic order, or in a cyclic way. So it is simple, easy to implement, and you don't have to starve the processes or wait for the processes to stay on the waiting time for a long time, since all of the processes will get a fair share when it comes to the scheduling in the CPU. So again, round robin scheduling, it is a fixed time. Fixed time is allocated for each process, and then it is called time quantum or quantum for execution, meaning to say all the processes are given an equal opportunity of which the CPU will schedule, which processes will be scheduled. And then once a process is executed for a given time period, that process is preempted already, and then other processes execute for a given time period. So this is the illustration. So we have the table again, process P1, P2, P3, P4, the same burst time or same milliseconds. So the Gantt chart will be, or the buffering will be, the P1 is allocated, we have, since it has given equal priority, we have P1, P2, P3, P4, and then again P1, P3, P1, P1, and P1, since all of it are in the average waiting time will be 11 milliseconds. Okay, so let's say for example for well, like in a real time scenario. Let's say for example, if you are working in your laptop, or if you're working with your a mainstream cell phone or mobile devices or desktop, uh, it's like for example, you're doing several application at the same time. You think that it's at the same time, but it's not. So let's say for example, you're typing your documentation in the Microsoft Word, and then your thesis, and then you are also listening to song at listening to media player or whatever songs you are listening, and then you are also surfing the net while you are listening to the song, and then typing words in the Microsoft Word as some backgrounds. And then you also think, and you think that processes are also running at the same time, or many processes are running parallelly or simultaneously, but it's not true, because CPU scheduling, or the processes that are running into your system, it is based on the time quantum, meaning this way, on the execution time, or the time that that the CPU scheduling is processes or processing. So for every process that is being inputted into your, that is being executed or going to execute into your system, the operating system will allocate some unit of time. So that is most probably in milliseconds, because that is how fast the processors are working, or that is how fast a multiprocessors is functioning. So again, though you think that all the apps that is running into your computer, you think that it's running at the same time, it's not, because it's the CPU scheduling who do all the works. So meaning to say, the CPU scheduling will allocate time, some unit of time, for each of the processes that is being executed in your computer, and then that time, that unit of time, is what we call milliseconds. And then it will only let's say for example, if you are playing with your media player with songs, and then you're hearing it, it will only take the CPU will allocate 2 milliseconds for that. And then maybe for the word or the documentations you are doing with your Microsoft Word, it will only take 3 milliseconds. And for other processing, it's running or presenting or something like that, the CPU will also schedule some unit of time, like 3 or 4 milliseconds, like what we are illustrating above with those with those this first come first serve, or this round robin, or this priority scheduling. And this switching between processes, like this switching is over the process, it takes so fast that sometimes it looks all the processes are running at the same time. Again, CPU scheduling will take or will allocate time for each of these processes to be completed. Okay, so I guess that's all. I hope you learned something, and then I hope you will be able to watch this video and then give comments, and then if you have any questions or clarifications or suggestions or whatever informations you can add, please let me know. Don't hesitate to message me in the chat box. And have a good day to all.